In this example, we're asked to solve the equation 3 to the 2x plus 3 to the x minus 2 equals 0. So we can identify that the variable appears as the exponent on these two bases, so we know this is an exponential equation. But if we look at this exponential equation, we can see first of all it would be impossible to write both sides with the same base because we've got this extra term here, this 2. So even if we move the 2 and one of the 3's over, we've got a constant in addition to these terms with the bases. So we won't be able to write both sides with the same base. And as far as using logarithms, that 2 on there makes this more difficult to directly use logarithms. So we need another method. If you look at this, you can see that we've got 3 to the 2x and then 3 to the x and then a constant. Okay, so if you note, 3 to the 2x power is the same as 3 to the x squared. Because power to a power, x times 2, you multiply those and get 2x. So it turns out that this first term is actually the second term squared. So what we can do is look at this as if it's a quadratic. Here's the first term is squared, here's this middle term to the first power, and then a constant. So we're going to treat it as if it's a quadratic. But in order to do that, we're going to have to use a substitution. So what we'll do is we're going to let u, we'll introduce a new variable u, and we'll let that equal 3 to the x. So then what we'll do, so this will become a u, this will become a u squared, and then this is a quadratic, so u squared plus u minus 2. So we just have to observe that that middle term 3 to the x, if it's squared, it gives you 3 to the 2x, and then that final term is a constant, and that's how we know that we're going to use this substitution method and treat it like a quadratic. So now I'll rewrite this as u squared plus u minus 2 equals 0. And now we have all of our methods to solve a quadratic. So it looks like it's going to easily factor, so we'll factor. So first terms need to be u. Last terms have to be 1 and 2. We need a negative and a positive. And if we check our outer and our inner products here, u times negative 1 is negative u. 2 times u is 2u. Negative u plus 2u will give us the middle term of u. So then we'll set our factors to 0. And so we'll get u equals negative 2 and u equals 1. But now, our problem doesn't have any u's in it. We made up that u. That u is just a convention that we're going to use to get back to the variable x. So you don't want to circle these as your answer because you made up that letter u. Now we've got to convert these back into x's. But that's using this conversion. So it's important that you write this down, how you converted, because if you just solve for u's, that's only halfway there. So now I'm going to substitute the negative 2 back into u for my conversion. So I'm putting a negative 2 in here for u, and now I'm going to put a 1 in here for u. So then I'll have 1 equals 3 to the x. Now once you substitute back, now you have more simple exponential equations that will allow you to solve for x. Now first of all here, as this is written, we have a base of a 3 and then a negative 2 here. So we can see there's no way to write a negative 2 and a 3 with the same base. So we'll have to use logarithms to rewrite this with the exponent, that variable out of the exponent. So we know we can rewrite this as log base 3 of negative 2 equals x. But this should jump out at you here. This argument is negative, and we can't take log of negative numbers. So we know that this is not one of our solutions. So if you just want to make a note here, the argument can't be negative. So we exclude that. That doesn't make sense. Now here, if we rewrite this using logarithms, now we'll have log base 3 of 1 equals x, and we know log of 1 is always 0. Remember, the power of 3 that gives us 1 is 0. Or even if you just go back to here, you might be able to just see it more easily here. This is saying 3 raised to some power equals 1. Well, the only power you can raise on any base and get 1 is a 0. So this is going to give us our x equals 0. So the key to these is identifying this new tool you have now in your math toolbox is to treat this like a quadratic, and the reason you can do it is because the middle term 3 to the x, if it's squared, it will give you that first term, which means you could rewrite that as a quadratic. So don't forget to write your conversion down, your u equals, so don't just go right from the original problem to the u's. You've got to explain how you converted, so that then when you get your answers down here, your u's, you can plug back in and get back to those x answers.